Alright, today we will discuss about different types of problems. So first type of problems under today's discussion is to solve some of the definite integrals. Okay, so solve I is equal to integral 0 to infinity. This is x to the power 3 by 2 into e to the minus x dx. All right, so this is the question. So now by just looking at the question, I should be able to understand that this question is directly coming from this beta gamma functions, and I should be able to relate this to either beta or gamma function. For example, let me recall. So we know that the gamma of any value n is equal to integral 0 to infinity. This is the first clue. If the integral is 0 to infinity, that gives a first clue that it is either beta or gamma. Okay, uh, and I have an e to the power function e to the minus x into x to the n minus 1 dx. You see that if you have something in this format, then this is a gamma function. I can solve this easily using gamma. So I can see that e to the minus x, e to the minus x to the power something, and x to the power something dx, which means this is the gamma function, right? I don't have to solve this manually. No manual integration is required. Simply find out what gamma function is this. So simply equate n minus 1 is equal to 3 by 2. When n minus 1 equal to 3 by 2, what is n? N is equal to 3 by 2 plus 1. So this is equal to 5 by 2. So given integral I is nothing but it's gamma of 5 by 2. Alright, so when gamma function of a 5 by 2, which is a real number, it's not an integer, it's nothing but it's n gamma of n plus 1 is n gamma n. I'm applying that. So this is 5 by 2 means I will start with 1 less than that. So this is 3 by 2 into 1 by 2 into gamma half. Correct? So this is what is the basic rule we studied earlier. So this is 3 by 4 into gamma half is root pi. So what is the answer? The answer is equal to 3 root pi whole divided by 4. Simple. So the application level problems, right, have been started now. Okay, so the next one is this. Fine. We'll go one level deeper. This is slightly tougher question. So solve I is equal to integral. This is 0 to infinity x to the 1 by 4 into e to the minus root x dx. All right. Again, the format is very similar to a gamma function, but it is not a proper gamma function because I don't see a e to the power minus x over there. I see e to the power minus root x. So it's not a proper gamma function. I have to bring this into a proper gamma function format. Then only I will be able to solve this. Okay, so what I do, so the trick here is you see e to the power minus, I want that term. If it is root x, cube root of x cubed, whatever you have to make a substitution for that term. In this case, I'm supposed to make a substitution for this term because I need a e to the power minus something which is not root, not cube root, not square, nothing. It should be a simple integer, simple variable like x, t, v, whatever. So I have to bring that now. So for that reason, I'm going to make a substitution. So put, say, t is equal to root x. This is my substitution. Now you see that if I make that substitution, I have e to the power minus t coming up over there. That's fine. Now, if you make this substitution, there is x in my equation, there is a dx in my equation. I need to make a substitution for that as well. So, this implies, what is your x? X will become t square. Because squaring, both sides you square, you get this. Also, I have a dx in my equation. So, what is dx? Dx is equal to 2t into dt. Right? And I need to find the limit for this. So when x equal to 0, I know that t also is 0. because x equal to t square. So t is equal to root x. Root of 0 is 0. Also, when x is equal to infinite, t is equal to root of infinity. That's also infinity. So my limits will not change now. That's what I understand from this. Therefore, after substitution, now I rewrite my equation. So this is t varying from 0 going till infinity. It is x to the power 1 by 4. But what is x? I know that x equal to t square. So this is t square to the power 1 by 4 into, after substitution, this becomes e to the power minus t. Okay, then there is a dx. Dx is nothing but 2t into dt. All right. Okay. Now, after this is equal to, the 2 is a constant. I'll bring the 2 outside. This is 0 to infinity. So there is a t square into 1 by 4. So this becomes 1 by 2. So 2 into 1 by 4, the power reduces to half. So this is t to the power 1 by 2 e to the minus t into, there is t to the 1 dt. Okay, so in the next step, I'll bring this into some standard format. This is 2 times 0 to infinity. So t to the half and t to the 1. I have to club them together. So the powers get added up. Half plus 1 is 3 by 2. So this becomes t to the power 3 by 2 into e to the minus t dt. Okay, so this means I can say that this is 2 times gamma of, I need to find out. So I will make a calculation here. So that 3 by 2 is nothing but n minus 1, like a previous problem, right? N minus 1 is equal to this, which means I'll come to know that, right? N is equal to how much? 5 by 2. So this is gamma of 2 times gamma of 5 by 2. So I know how to calculate gamma 5 by 2. Gamma 5 by 2 is 1 less than that. 3 by 2 into 1 by 2 into root pi. Root pi is coming because there is a gamma half. So this will cancel. So the answer is 3 root pi by 2. That's what is the given integral. Okay, pretty straightforward. Let's go ahead. Right. The next question is this. Solve I is equal to integral 0 to infinity. This is x to the 6 e to the minus 2x dx. Right. Once again, my approach remains very much similar to the previous example. I know that e to the power, some simple variable I am expecting, but there is a 2x here. So I don't want the 2x, I have to make a substitution. So what is the substitution? Put some variable t is equal to 2x. So t equal to 2x implies wherever I have x, I have to write that as t by 2. Okay, and also I have a dx present in my equation. Wherever I see a dx, I am going to write that as dt by 2. Okay, again I need to find out the limit now. So when x equal to 0, the t becomes equal to 2 into 0, that's 0. Also, when x is equal to infinity, the upper limit, t becomes equal to 2 times infinity, that's also infinity. Okay, so therefore, now after this substitution, my integration becomes integral 0 to infinity. I don't have an x over there. Instead of x, I have to write t by 2 to the power 6 e to the power minus t. So there is a dx which is dt by 2. Alright, so this is equal to, now I'll take out all the 2 to the powers out. So you see that there is a 2 to the power 6 in the denominator and there is one more 2 after this. So I'll highlight that. So I'm talking about this and this. So you club them together, 2 to the power 6 and one more 2. So this becomes 2 to the power 7. So that is 1 divided by 2 to the power 7, which comes out. Then integral 0 to infinity. This is t to the power 6 into e to the power minus t dt. Now the second term is in the required format. The n minus 1 is equal to 6, so n is equal to 7. Correct? Now, so let's do this calculation. This is equal to 1 over 2 to the 7. If you calculate, that comes to be 128 into, this is gamma of n is equal to 7, because just now we calculated gamma equal, that n value is equal to 7. So this is equal to gamma 7 is how much? Gamma n is, if n is integer, you remember this has to be n minus 1 factorial. N minus 1 is how much? 6 factorial. 6 factorial by 128. So if you calculate the 6 factorial, that is 720 by 128. Upon simplification, this reduces to 45 by 8. That is the required answer. So you see that the trick here is convert the given problem, irrespective of whatever is the integral, you need to convert that directly into the standard gamma function. Bring it into any of the gamma function so that you will be able to solve that using any easier method. Okay, so that's the idea. All right, now let's go to another question. So this is solve I is equal to integral 0 to 1. This is root of minus log x dx. Okay, now we see that this question does not belong to any of the standard standard integral, or it's neither a gamma function or nor a beta function. So now this is the next level problem where I need to bring this into the required format first. So solution comes only from practice. You have to practice variety of problems to come to know what is the exact substitution that you are going to make. All right, whenever we have a log, it is easier to bring a e to the power by taking an anti-log. So what I do, I make an assumption here. So we'll put minus log x. I'll try to replace that itself as a t. Okay, so if I do this, now I can take the log x. This means log x equal to minus t. Right. So now just now I told you can bring a e to the power if you take a anti-log. So taking anti-log. Okay, anti-log means log will cancel. This is x. Anti-log is actually e to the power minus t. I got x. Now I can see that there is a dx. So what do you substitute for dx? Dx is equal to differentiation of e to the minus t, which is minus of e to the power minus t into dt. Okay, I got this. So I know what is minus log x, which is t. Okay, and I have dx. I know dx, the value of dx also, which is minus e to the minus t into dt. So we got these two. Now I need to substitute something for the limits, because limit has to change. Previously it was x, now it is t. So x equal to, let's do the calculation. Initially I know that the lower limit x equal to 0. This implies what happens to t? T is equal to minus of log x. Right? So x equal to 0 indicates, right? I can check this. X equal to 0 implies I can use this also. If the original, this substitution is difficult for us to understand, right? I can go to x equal to e to the minus t, right? So this is, you can make the left hand side 0 in the x equal to this term. So 0 is equal to e to the minus t, right? So log of 0 is actually undefined, right? So it makes it infinity. So t becomes equal to infinity when x is 0, t equal to infinity. Similarly, the upper limit, when you take x equal to 1, right? X equal to 1 means log 1. Log 1 is 0. So t becomes equal to 0. Alright, so we got the values now. Now I need to use all these values we found so far, and we need to substitute this into the equation. Okay, so let's substitute. Therefore, the I value becomes equal to lower limit t becomes equal to infinity, upper limit t becomes equal to 0. And I had an equation like root of minus log x. Root of the minus log x was substituted as t. Okay, and I had a dx is nothing but minus of e to the power minus t into dt. This is the dx, right? Now what happens, I can cancel the minus by flipping the limits of integration. So this becomes now 0 to infinity, right? Root t I can write as t to the power half into e to the minus t dt. All right, now you can see that this is in the required gamma function format with, right, the n minus 1 becoming equal to half. Means what? N equal to half plus 1. Half plus 1 is 3 by 2. So that means this whole function is nothing but gamma of 3 by 2. What is gamma 3 by 2? It is 1 by 2 into root pi. So the answer is simply root pi by 2. So see the advantage. No need to solve any integration. Just bring it into the format and get the value using the what is called as a gamma or beta function. All right. Then let's go further. Okay, the next question. Okay, the next question I want to solve is this. This is integral I is equal to, this is integral 0 to 1. This is x log x raised to the power 4 into dx. So fine, what I do, I slightly modify this. I separate the powers, x to the power 4, okay, into, this is log x whole to the power 4 dx. Okay, now I have a solution here. Again, log x is not valid, but if you take an anti-log, you can convert this into a e to the power. I know that. So always remember, if you see a log function in the given integral, you have to take a anti-log somewhere to convert that into e to the power and get the whole thing into the gamma function format. Okay, so what I do, I put the log x, put the log x is equal to minus t. Now we see that if you put simply log x equal to t, I am not able to bring the e to the power minus t format. So for that reason, I am going to put this as minus t. So taking anti-log, x becomes equal to e to the power minus t. X I got now. I also have what is called as the dx. So what happens to dx? Dx equal to minus e to the power minus t into dt. And very similar limits. So when x equal to 0, what happens to t? T becomes equal to infinity. Because the same explanation like the previous problem, so I'm simply writing the limits. X equal to 1, this implies that t becomes equal to 0. So substituting everything into my equation, so I is equal to integral. Now you see t becomes varying from infinity to 0. There is a x. What is x? X is equal to e to the power minus t. So this power 4. Okay. All right, I got this. And next term is log x. If you remember, we substituted log x as minus t. So minus t to the power 4, and we have a dx. So what is dx? Dx is equal to, you can see that we substitute as minus e to the power minus t dt. Alright, so this is equal to, I can rewrite this as, this is equal to, you see here, this is integral infinity to 0. This is e to the power, there is a 1 minus t minus 4t, okay, into minus of t to the 4 is nothing but simply t to the 4, into minus of e to the minus t dt. So this minus I can cancel now by flipping the limits of integral. This is 0 to infinity, that minus gets cancelled. Let me club the e to the powers. E to the power minus 4t and minus t is e to the power minus 5t into t to the 4 dt. Okay, now we have something in our hands, but this is still not in the required format. You see, we expect e to the power a variable, simple variable like x, t or something. Now I have a minus 5t. So what happens? This problem is in a different state now, but I can definitely make another substitution to bring this into the required format. So what I do, I make another substitution. So that is put u is equal to 5t. Okay, so this means what is t? T is equal to u by 5. Okay, which means I have a dt to substitute, which is du by 5. Okay, so under this condition, I have to find what is the limit of u now, because the problem is in terms of t. I have to convert into u. So t is equal to 0 implies what happens to u? U becomes, u is equal to 5 into 0. So this is still 0. Also, t equal to infinity implies u is equal to 5 times infinity. That's also infinity. So no change with the limits. So we'll make this second time substitution to the same problem. So I is equal to 0 to infinity will remain same, 0 to infinity for u, then make a substitution. So this becomes e to the power minus 5t is what? 5t is u, so this is e to the minus u into, wherever I see a t is nothing but u by 5. So this means it's power 4, and I have a dt is nothing but du by 5. So clubbing them all together, I can take 5 to the power 4 and one more 5 outside. So this becomes equal to 1 over 5 to the power 5. That's because 5 to the 4 comes from one term and another 5 comes from this side. So that is 5 to the 5 integral 0 to infinity. Write it in the required format, that is e to the minus u to the power 4 into du. So now I understand that this is in the required gamma function format with n minus 1 should be equal to 4. So what is n? N equal to 5. So whatever is inside the integral, that is a gamma function. So this is 1 by 5 to the 5 into gamma function of 5. Gamma 5 is what? 4 factorial. So this whole thing becomes 4 factorial divided by 5 to the power 5. 5 to the power 5. So when you simplify, 4 factorial is 24. 5 to the 5 is 625 and 5. So 3125 is the required answer. Okay. So these are the other types of problems that normally comes when it comes to the gamma functions. Okay, so fine. Now, before going ahead, we will solve some problems based on the beta functions as well. So just before that, let's try to recall what we had studied already related to a beta function. Okay, so we slightly modify the equations of beta function so that we can solve a little bit of more difficult problems. So that's our objective now. So what we do, I'll start from this. We know the definition of a beta function. So that is beta of, if I write m comma n, this is nothing but 2 times integral 0 to pi by 2. This is sine to the power 2m minus 1 times theta cos of 2n minus 1 into theta into d theta. Okay, now for making this more easier to solve more complex problems, what we do, we put the 2m minus 1 as p. Okay, and I also make a substitution that the 2n minus 1 in the equation, I'm going to call this as a q. All right, so what happens here, let's do some more calculation. So this means 2m is equal to the p plus 1. So m becomes equal to the p plus 1 divided by 2, right? So similar to this, I can also write on the other side the 2n is equal to q plus 1 and n becoming equal to q plus 1 by 2. Okay, now you see in the main equation I'm going to make the following changes. I know the m and n, therefore see the beta function, beta of m is nothing but p plus 1 by 2 and n is nothing but q plus 1 by 2. This is equal to 2 times integral 0 to pi by 2. Now instead of writing the equation in terms of m and n, I'm going to write in terms of p and q, because 2m minus 1 is p as per my assumption. So this is sine to the power p theta into cos to the power q theta into d theta. Or otherwise, if at all, you see, if the question is asked in this format, 0 to pi by 2 sine to the power p theta into cos to the power q theta d theta, if this means the 2 will go to the other side, so that is half of beta function of the whatever is the p, it's p plus 1 by 2 comma q plus 1 by 2. Very simple. So I just have to, I see the 0 to pi by 2 integral sine to the power p theta cos to the power q theta d theta means I don't have to solve any integration. Simply take half of beta of p plus 1 by 2 comma q plus 1 by 2, because beta of m comma n I know how to solve. Right? I can convert that into gamma m gamma n by gamma of m plus n. Very simple, right? Already we have solved many questions based on that. So this becomes very easy for us to solve. Okay, now, so let's go ahead and calculate some of the questions based on this. Okay, now, so the first question. Solve I is equal to integral 0 to pi by 2. This is sine to the power 4 theta cos to the power 3 theta d theta. So what I am supposed to do this? Simply compare the given equation with this term. Right? 0 to pi by 2 sine to the power p theta cos to the power q theta d theta. I can compare and I can understand that the p becomes equal to 4 and q becoming equal to how much? Q is equal to 3. So I know that this means I can directly write this as half of the beta function of p plus 1 by 2. So what is p plus 1? So this is 4 plus 1 by 2 comma this is 3 plus 1 by 2. Simply compare them. Okay, so this is half of the beta function of 4 plus 1 is 5 by 2, comma 3 plus 1 is 4 by 2 is 2. Alright, so I know that the solution is beta of m comma n is nothing but gamma of m is equal to 5 by 2 into gamma of n is equal to 2 divided by the gamma function of m plus n, 5 by 2 plus 2, right? 5 by 2 plus 2 is 9 by 2. Right. So already we solved these functions individually. I can simply club them together to get the answer. So half into gamma 5 by 2. How do you find out? Gamma 5 by 2 is nothing but this is, you start from 1 less than that. Correct? So this is 3 by 2 into 1 by 2 into root pi. That's the first term. Into gamma 2 is nothing but 1 less than that. So it's factorial. It's a whole number integer. So gamma 2 is 1 factorial. Whole divided by gamma 9 by 2. Gamma 9 by 2 is 9 by 2 minus 1, that is 7 by 2 into 1 less than that, 5 by 2 into 1 less than that, 3 by 2 into half into root pi. So I know that 3 by 2, 1 by 2, root pi will cancel with the denominator. 1 factorial is simply 1. Alright, so this means this 2 will cancel with this 2. Right, so what happens in the final answer? The 2 in the denominator will go to the numerator. 7 into 5 is 35 is the final answer. So given question is pretty much difficult to solve if we go through the normal integration procedure, but now you know that if you are able to convert that into a given function like this, standard function like this, using beta or gamma function, it becomes pretty easy for us to solve. All right, let's go to another question. All right. Next question. I is equal to integral 0 to pi by 2. This is sine to the power 6 theta d theta. Okay, I can definitely rewrite this in order to get into my standard format. That is 0 to pi by 2. This is sine to the power 6 theta. See, cos to the power 0 theta, right? Cos to the anything to the 0 is 1. Okay, into d theta. Now you can actually compare. So what is the p? P is equal to 6. What is q? Q equal to 0. So this means the given function I can be written as half of the beta function of p plus 1 by 2. So p plus 1 is 6 plus 1, that is 7 by 2. Comma, q is 0. 0 plus 1 is 1. Divided by 2 is half. 7 by 2 comma 1 by 2. So that means it is half of beta of 7 by 2, means you convert this into gamma 7 by 2, gamma 7 by 2 into gamma of 1 by 2 whole divided by gamma of 7 by 2 plus 1 by 2. 7 by 2 plus 1 by 2 is 8 by 2. 8 by 2 is 4. Alright, so this becomes pretty simple now because it is gamma 7 by 2 is actually 5 by 2 into 3 by 2 into 1 by 2 into root pi into gamma half is once again root pi. Alright, whole divided by, this is 4. 4 means what? 4 means it is 3 factorial. Right? So 3 factorial. Okay, so this becomes, I'll keep the pi as it is because root pi into root pi is a pi. Then let's try to remember, simplify this. 5 into 3 divided by 16 into 3, 3 cancels. This is simply 5 pi divided by 4, 16 into 2, so 32. Alright, very simple answer. Okay, now let's go ahead. Very similar question now. Instead of sine, I'm going to give a cos now. So that is integral 0 to pi by 2. This is cos to the power 7 theta d theta. So I know that I need a sine value as well. So that's why this becomes equal to 0 to pi by 2 sine to the power 0 theta into cos to the power, not 0, my mistake, because the given value says cos to the power 7. Alright, so because of that, this is equal to cos to the 7 theta d theta. So this means P is equal to 0, Q is equal to 7. So the given thing becomes equal to half of beta of 0 plus 1, that is 1 by 2, comma 7 plus 1 is 8 by 2, so that is 4. So now if you simplify this further, this becomes equal to half of beta of half comma 4 is nothing but gamma half into gamma 4 divided by gamma of half plus 4. 4 plus 1 by 2 is 9 by 2. I just have to simplify this now. So this is equal to half. Gamma half is root pi into gamma 4 is 3 factorial whole divided by gamma 9 by 2 is 7 by 2 into 5 by 2 into 3 by 2 into 1 by 2 into root pi. So root pi cancels, this half cancels with this half. Okay, so that means 3 factorial is 6 and the denominator has 2 into 2 into 2. Okay, so that becomes 1 by 6 into this. Okay, so this becomes, this is equal to 16 divided by 35. Final answer is the required I. Alright. Now let's go to another type of problem. Again, these problems are based on the beta functions. Alright. So the next question to solve now is this one. Solve I is equal to integral 0 to 1 x to the 3 by 2 into 1 minus x to the 1 by 2 dx. So now there is no e to the power, there is no log. So when I don't have a log or e to the power, this is not a gamma function. That's how I identified. So if there is a x and 1 minus x, this is going to be a beta function. Okay, so I need to convert this into a beta function. So let me recall, right? We know that beta of m comma n is nothing but integral 0 to 1. X will be raised to the power m minus 1 and 1 minus x will be raised to the power n minus 1 into dx. So comparing these two equations, I understand that in the given question, the m minus 1 is nothing but 3 by 2 and the n minus 1 is nothing but 1 by 2. Okay, so what is m now? 3 by 2 plus 1. So that is 5 by 2. Similarly, I come to know that n is equal to half plus 1. So half plus 1 is 3 by 2. So once I understand this, now the given question I is nothing but it's a simple beta function. So what is the beta? This is beta of m comma n, that is 5 by 2 comma 3 by 2. No need to solve the integration, simply get the answer of beta function. So how do you do that? This is beta of m comma n is gamma of m 5 by 2 into gamma of n 3 by 2 all divided by the gamma of m plus n. So this is 5 plus 3, 8 by 2, so this is 4. All right, so that is 5 by 2 gamma function is nothing but 3 by 2 into 1 by 2 into root pi. This is the first gamma function. Second gamma function is 1 by 2 into root pi whole divided by gamma 4 is nothing but 3 factorials, 3 into 2 into 1. Okay, now we'll simplify this. The root pi into root pi becomes a pi, and 3 into 2 is 6. 2 into 2 will cancel with that as this, and we have, okay, so there is a 3 in the numerator, so this becomes 3 pi divided by 2 into 2 into 2 into 2. Okay, this is 3 pi by 48, so 3 will cancel with this as pi by 16. All right, so the given integral answer of that is nothing but pi by 16. So beta and gamma functions help us in solving a very difficult integration problem. That's what I told at the introduction class. What are the applications? So applications are like this. Okay, then the next question is solve I is equal to integral 0 to 1. This is root of 1 minus x by x into dx. Okay, all right, so now I can see a x and I can see a 1 minus x, but this is not in the standard format. I have to convert this somehow. So what I do here, I'll write their powers separately. I separate the powers. This is 1 minus x to the power half into x to the power minus half, because x in the denominator and there is a root. So 1 minus x to the half, x to the power minus half dx. Now I can see that yes, this can be written in the form of a beta function. How do you do that? You need to find m is equal to m minus 1, my mistake, it's not m minus 1 should be equated to the x to the power whatever you have. So I can write m is equal to m minus 1, this is equal to minus half. So when I say m minus 1 is equal to minus 1 by 2, this becomes m is equal to minus half plus 1, so that is equal to plus half. All right, very similar to this, I'll check what is n. So that is n minus 1 is equal to how much? It is plus half, because 1 minus x is raised to the power positive half. So n becomes equal to how much? N becomes equal to simply 3 by 2. 1 by 2 plus 1. So this indicates that my solution is going to be very simple now. The I is equal to, therefore, I is equal to, this whole function is a beta function of m is equal to half and n is equal to 3 by 2. Right? Now we know what to do. This is equal to gamma half gamma 3 by 2 whole divided by gamma 3 by 2 plus 1 by 2. Right? That is 4 by 2, which is 2. Alright, so this answer is equal to gamma half is root pi, gamma 3 by 2 is 1 by 2 into root pi, and gamma 2 is nothing but 1 factorial. So root pi into root pi is pi, and there is a 2 in the denominator, so the answer becomes equal to simply pi by 2. Okay, so this is level 1 question based on the beta functions. Now let's go further, right? The questions can be made slightly tougher, right? By giving the data as follows. Let's say, okay, this is a question. Solve I is equal to integral 0 to 2. This is 4 minus x square to the power 3 by 2 dx. Okay, so remember one thing, you remember, if I have a term like a square minus x square coming up, you see that this is a square, 2 square. Okay, if you have something like that, then you are going to make a substitution like, the substitution is going to be a sine theta. You need to find out what is the a. A is 2 here. Okay, I'll write this point for your reference. Okay, I'll write that here as a note. Note, that is, if you find out a square minus x square term, right, this implies you are going to substitute. You have to substitute this, then only we get an answer. Okay, then substitute x is equal to a sine theta. This is the point to remember. Now I can see that there is a square minus x square, a being equal to 2. This is 2 square minus x square. This means what? Put, I have to use the same logic. Put x is equal to a sine theta. A is nothing but 2. This is 2 sine theta. Fine. This means I have a dx in the given equation. So dx becomes equal to, right, sine theta differentiation is cos theta. There is a constant 2 outside. So 2 into, this is cos theta into d theta. Okay, now since I'm actually substituting, replacing x by theta, I need to find out what is the limit as well. Okay, so I have minimum limit, lower limit, x equal to 0. X equal to 0 implies I need to find out what is the theta, right? So theta is equal to sine inverse of x by 2. So x is 0, so sine inverse of 0 becomes equal to 0. So that means theta is equal to 0. Similarly, I know that x is equal to 2 as the upper limit, right? This means 2 sine theta is equal to 2. 2 will get cancelled. Sine theta is 1, right? What is the angle with sine 1? That is pi by 2. So theta becomes equal to pi by 2. This is the upper limit. Okay, so normal change of limits, that's all. So apply this now. So this means, therefore, the I becomes equal to now integral, the theta becoming varying from 0 to pi by 2, right? So look at that. It has 4 minus x square. So what I write here is, inside the whole power is being raised. This is 4 minus x square. X square is 2 sine theta whole square. So this is 2 square. So 4 sine square theta, because it's a x square, x is 2 sine theta, the whole square, 4 sine square theta to the power 3 by 2. Okay, to the power 3 by 2 into, so dx is 2 cos theta d theta. Right, this is the substitution. Now you see that this becomes very simple now after this simplification. So this is 0 to pi by 2. What I do here, I'll take 4 outside. 4 into 1 minus sine square theta inside the smaller bracket. This whole thing is raised to the power 3 by 2 into 2 cos theta d theta. So there is a 2 here, and you see that there is a 4 to the, okay, let me simplify further. Let me keep this as it is just to avoid confusion. This is 4 by 2 into, what is this? This is 4. 1 minus sine square theta is nothing but cos square theta. See, I am substituting 1 minus cos square theta, 1 minus sine square theta is cos square theta, because cos square theta plus sine square theta is 1. So if you want simply 1 minus cos square, it is cos 1 minus sine square, that is cos square theta. Okay, this raised to the power 3 by 2, which is outside. Okay, then into 2 cos theta d theta. All right, now you see there is 4. 4 is nothing but 2 square. 2 square and the 2 in the power will cancel. 1 by 2 in the power, they will cancel each other. That is 2 square. So you have 2 cube coming up. What is 2 cube? 2 into 2 into 2, that is 8. 4 to the power 3 by 2 is nothing but simply 8. So 8 into, there is a 2 here. So that 2 becomes, when I multiply, so 8 into 2, so this becomes equal to 16. Okay, so the whole term becomes equal to 16 in the outside this integral. So this is 16 times integral 0 to pi by 2. See, there is a cos square and the power half will cancel, only cube will come. So cos cube into cos is cos to the power 4 theta d theta. Now you know that this is pretty simple. This is equal to 16. So I can see that sine has no power, p is equal to 0 and q equal to 4, which means this is nothing but 16 into half of the beta value of p plus 1 by 2, which is half. Q plus 1 by 2 is 4 plus 1 by 2, which is 5 by 2. Okay, so this is cancelling with that 8. Right, now you can see that this is 8 into, this is gamma 1 by 2 gamma 5 by 2 whole divided by gamma of 1 by 2 plus 5 by 2. 1 plus 5 is 6, 6 by 2, which is equal to 3. All right, so as a result, this can be further simplified as follows. So this is 3 into gamma half is root pi into, there is a gamma 5 by 2, which is 3 by 2 into 1 by 2 into root pi whole divided by gamma 3 is nothing but 2 factorial. All right, so sorry, there is a 8 here, my mistake. So 2 into 2 into 2, that will cancel. So this 2, 2 factorial and 8 will cancel because 8 in the numerator, other terms are in the denominator. So this is 3, root pi into root pi is pi. So the final answer for the given integral is nothing but 3 pi.